This is the Nvidia GeForce GTX 1650, and we're going to overclock and benchmark it. Now, before we jump into all the awesome benchmarking, let's take a look at this graphics card and see what we're dealing with. The GTX 1650 is a mid-range graphics card that was first introduced in early 2019. It's based on the TU116 and TU117 graphics processors, has 896 CUDA cores, and supports DirectX 12. The card runs between 1410 and 1485 MHz core clock and between 1500 and 2001 MHz memory clock. The card comes in both full height and low profile versions and features single or dual cooling fans. The GTX 1650 comes with 4 GB of GDDR5 or GDDR6 memory. Versions of this card can use between 75 and 85 watts of power and can be powered either solely through the PCI slot or feature an additional 6-pin power connector. The example card we have here is the Zotac GTX 1650 amp core, which does feature an additional 6-pin power connector. This extra power should give us a slight advantage when it comes to potential overclock values. So let's get ready to overclock and benchmark this compact powerhouse and see what kind of performance we can push out of it. The first thing we did was update the drivers. The GeForce 531.61 drivers are the newest ones Nvidia offers for this card, so we installed those. I'll put a link to them in the description. The overclocking utility we used is Nvidia Inspector 1987. If you don't know Nvidia Inspector, it's a totally free tool. I'll put a link in the description. Now that we've unzipped the program and run the Nvidia Inspector.exe file, let's take a look at the key settings we'll be using. Click on the Show Overclocking button. Warning! And be sure to read the important warning. I'd recommend being very careful when changing around the voltage on your card especially, and only do it in small increments. Fortunately, we're not doing anything too crazy here today, and Nvidia Inspector will only allow us to choose values within a certain range. For this card, the values we'll be changing are the base clock, memory clock, and power values. You can always reset your settings back to default by clicking the Apply Defaults button along the bottom. Once you're satisfied with your changes, you can click the Apply Clocks button to apply them. Now I'm going to put a list of known successful GTX 1650 overclocks on the screen. Every card is different, but this should give you a good starting point for finding potential overclock values that may work for you. Once we've locked in some potential overclock settings, we're going to want to test them. We'll be running through 10 different programs with benchmarks to test our overclock for stability and performance. Now, a lot of these benchmark programs are free. I'll put a list of some of them in the description. So what I'll do first is run through all 10 benchmarks using the stock settings to measure base level performance numbers. Then I'll select a minor initial increase in both core clock and memory clock values. I'll then run through the UNIGINE benchmark tool over and over while increasing the overclock values slightly each time. Once the benchmark fails, I'll then go in, boost the power slightly, and run it again. Now, once the settings have been pushed too far and I start seeing crashing, graphical glitches, degraded performance, or any type of odd behavior, I'll dial back the settings to where they were just previously when everything was still running smoothly. At this point, I now have a solid idea of where the sweet spot is for overclocking my particular card. I can either stick with those settings or try tweaking things just a little further. After a number of tests, this particular card was able to reach a solid overclock of 140 MHz core clock and 700 MHz memory clock. This seems fairly respectable compared to the other example overclocks in the list. Can we maybe get a 10% increase out of this card? Well, let's run through each of the 10 benchmarks to see how our GTX 1650 performed. First up, it's UNIGINE Superposition. Running at the 1080p medium preset, base results achieved a score of 7400. After overclock, the score increased to 8003. That's an increase of 8.1%. So not quite 10%, but it's the same ballpark.
It's the same ballpark.
Let's see how our other benchmarks did. Next up, it's 3D Mark. Running the TimeSpy test at default settings, the initial graphics score came in at 3802. After overclock, graphics score increased to 4144. That's an increase of 9%, so even a bit higher than the last test. Next up, it's Grand Theft Auto 5 benchmark. Running at 1080p, 100% resolution scaling, and the highest possible settings, initial average FPS came in at 34.8. After overclock, average FPS increased to 37.9. That's an increase of 8.9%. A nice boost for sure, though you may want to dial back the settings just a bit for a playable experience here. Next up, it's Shadow of the Tomb Raider Trial. Running at 1080p in the medium preset, initial frames rendered came out to 10918. After overclock, frames rendered increased to 11793. That's an increase of 8%, so it's another solid increase for Tomb Raider. Next, for all our video editors out there, we've got Blackmagic Raw Speed Test. Testing the performance for decoding 1080p raw video files, initial results came in at 968 frames per second. After overclocking, results increased to 1004 frames per second. That's an increase of 3.7%. So, not a huge boost to be had here. However, still some impressive numbers overall. Next up, it's Red Dead Redemption 2 Benchmark. Running at 1080p 100% resolution scaling and the lowest preset, initial average FPS came in at 65.1. After overclock, average FPS increased to 69.8. That's an increase of 7.2%. So it's another decent boost to be had for this title. Next up, it's GFXBench 5. Running the Aztec Ruins test at 1080p normal mode, initial average FPS came in at 262.7. After overclock, average FPS increased to 290.2. That's an increase of 10.5%. So an impressive increase to be had here, right in line with our 10% goal. Next up, it's Forza Horizon 4 Benchmark. Running at 1080p in the medium preset, initial average FPS came in at 108.6. After overclock, average FPS increased to 120.9. That's an increase of 11.3%. It's a nice boost to performance to be had here. Your mileage may vary. Next up, it's CSGO Benchmark Map. Running at 1080p in the highest possible settings, base FPS came in at 203.3. After overclock, average FPS increased to 211.3. That's an increase of 3.9%. So, not too much to be had here. What's next?
What's next?
Next, it's Borderlands 3 Benchmark. Running at 1080p, 100% resolution scaling in the medium preset, initial average FPS came in at 53.0. After overclock, average FPS increased to 56.9. That's an increase of 7.4%. So it's another noticeable boost to performance for Borderlands 3. Next up, it's Final Fantasy XIV Endwalker. Running at 1080p in the high preset, base clocks achieved a total score of 10930 or high rating. After overclock, total score increased to 11556 or very high rating. That's an increase of 5.7%. It's a minor boost to performance for this title, but we'll take it.
We'll take it!
So, how does our GTX 1650 stack up against other popular 1080p budget cards? Well, taking a look at some of them side by side shows the GTX 1650 in a solid position. The 1650 comes out comfortably ahead of the GTX 1050 and 1050 Ti, which both use roughly the same power. The card performs very similar to the AMD RX 570, falling within just a few percentage points, yet consuming only half the power of the RX 570. So there you have it, the Nvidia GeForce GTX 1650 in all its glory. A compact and solid mid-range 1080p performer with modest overclocking abilities. Please feel free to leave a comment, and thanks for watching.